Okay, I'm on my way to work. This morning I kind of watched some of those videos that I posted just to, check the information that I gave, and I found I made a few mistakes. I did some research, and I need to issue a corrigendum. So this is a corrigendum video on those mistakes that I made. Now, I'm supposedly an academic, right? I'm a teacher, so I have to make sure that the information I give you is accurate. So there are three things that I made that I realized are mistakes. Okay, the first one is something on lists in one of the very early videos. Now I kind of said briefly that the list is probably a linked list. Now I did the research. A list in .NET C# is actually an array in behind it. Okay, it's still an array, but that said, I would like you to go and read up on what a linked list is. Linked list is a very important data structure in computer science. Okay, and it's a pretty useful data structure. There is a linked list in C# and in .NET. Okay, so linked list is not as memory efficient as an array, but it allows you to do more manipulations to it. You can add things in between. You can add things to the two ends, the front and the back of it. Whereas an array, actually traditionally an array in computer science is hard to manipulate, because in computer science, when you traditionally when you allocate an array, it is a fixed set of memory. Like if I had 6 slots in an array, that is it. I can only put 6 things inside. If I wanted to add the 7th item, I actually had to vacate the memory, make a new one, and copy everything over. Okay, so the reason being, because when I allocate memory, the front and the back are filled with other things that while your computer runs, it uses up the memory, right? It doesn't like leave gaps everywhere. So when you allocate only 6 blocks of memory and you want to add the 7th, you have to basically make the 7th block somewhere else and copy the 6 over. So it's very inefficient to work on arrays. There are ways to make arrays more efficient, but that's for you to go read up and find out. It's outside the scope of this module. The second thing that I made a mistake on is on the integer ranges. Now in the topic on events, I did share with you there are 3 types of basically whole number data types. So there's short, integer, and long that I shared, and I gave some ranges. Those ranges are for what we call an unsigned integer, or unsigned short and long. So u short, u int, and u long, those are the ranges that I gave. Now for the signed one, which is int, right? Int is a signed integer, has negative values. The ranges is basically half on the positive side and half on the negative side. So for the exact range, just go Google, .NET integer value types, and you'll get the range on the internet. Okay, so that's a correction on that one. The third correction I want to make is the last video on Unity's main thread execution order. Now, I gave an example about the physics thing. Actually, that's a really bad example, and I would say, that's wrong. I read online about the main thread. Now, the information about this is very fuzzy. It's not very well published. There's some information that Unity provides, but it's still, to me, a bit fuzzy and not very clear why. Now, the reason that Unity gave is the reason why you have to use the main thread to call Unity's API. That's the important part. The main thread is for you to call the Unity API. What is the Unity API? Things like add force, right? Changing the position and the rotation of things, manipulating things on your GUI. These are all Unity APIs, basically talking to Unity to make changes to your scene and your GUI. Okay, so anything that has to do with Unity goes through the main thread is because Unity's API is not thread safe. Behind the scenes, Unity does multi-thread some things. Unity does do certain things behind the scenes to make sure that things there are no wonky things happening while it's doing its job. So for example, if I changed my game object's position while Unity is rendering the scene, that will screw things up, because physics would have done its job. It would have calculated if there's a collision, so on and so forth. And if you move something and at that time it was rendering the scene, you would have seen the moved thing being rendered before physics did its job, before animation did its job, before whatever. So that would be a pile of mess, right? So Unity definitely there are things that would happen in sequence. For example, you would have to have your physics and your animation go first before you render the scene. Otherwise, if you render the scene and then you did your physics, that would be bad, because your physics would you know, whatever your physics did, like you know, bouncing a ball, you know, any collisions will not be shown in your graphics rendering. So those things have to happen in sequence for sure. But within the physics engine, some things are multi-threaded, and that's a complex topic. I cannot explain it clearly. I'm not an expert at it. So you need to consult an expert source for that information. But anyhow, the main thread is there. It's for you to call the main thread, because the things in Unity are not thread safe, and Unity forces you to do all Unity API calls through the main thread, and inside it dispatches things to other threads. That's up to Unity to decide, and that's the whole point of the main thread. Okay, hopefully this is something that is useful for you. But if you want to know more about threading to help improve the game performance, you can read up on it. What I would advise is, if they are computationally intensive things, you want them in a thread. Now, whether it's on the main thread is a separate issue. If you could do computationally intensive things away from the main thread, say I'm doing a lot of calculations and I save the values for later, for the next update to pick it up, then I use a regular thread and let your operating system decide which CPU to put the thread on. Okay, and that would basically allow your code to run faster. You could and if you know what coroutines are, they're very different from threads. So if you have something really computationally intensive, put it in a thread. Don't put it in coroutines, and don't run it on the main thread. Okay, so main thread and coroutines will still affect the performance of your whole Unity execution loop. So that's the thing about threads, and I hope this is clear enough. And yeah, I'm going to work. Enjoy a day in school.